In Oregon and Washington have been identified by the U.S. Geological Survey as very high threat volcanoes: Mount Hood, Mount St. Helens, and Mount Rainier.
You can see this tremendous fountain behind me right now. It's blasting lava up to 200 feet into the air.
The Pacific Northwest has to be one of the most gorgeous parts of the U.S. It's got everything: rugged coastlines, dense forests, and mountains. It's not just about the scenery, though. This region has a way of blending natural beauty with innovation and culture, giving us some pretty big names like Microsoft and Starbucks. But while it's full of life and natural beauty, there's also a hidden threat: the Cascadia Subduction Zone, a fault line that could trigger a huge earthquake someday. The Cascadia Subduction Zone. The Cascadia Subduction Zone is a huge fault line stretching over 600 miles, starting in Northern California and running through Oregon and Washington, all the way to Vancouver Island in British Columbia. It's where the Juan de Fuca plate is sliding underneath the North American plate, and this interaction is behind a lot of the region's dramatic landscapes, like the Cascade Range volcanoes. Think Mount Rainier, Mount Hood, and the Olympic Peninsula. These landforms are key to understanding the area's past and what could happen in the future. To get a feel for the forces shaping this region, let's start at Hat Creek Rim Scenic Overlook in Northern California. From here, you can see Mount Shasta, a massive and active volcano at the southern edge of the Cascadia Subduction Zone. Standing at 14,179 feet, it's the second highest peak in the Cascade Range and the largest in terms of volume, with a whopping 85 cubic miles of rock. It's not just a sight to behold, though. Mount Shasta is also sacred to Native American tribes like the Modoc. In Modoc legend, Mount Shasta was created by the chief of the sky spirits, who piled ice and snow from the heavens to form a mountain full of power and majesty. It's a beautiful story, but geologists have a different take on how this iconic mountain came to be. Like all the volcanoes in the Cascade Range, Mount Shasta owes its existence to the Cascadia Subduction Zone. The Cascadia Subduction Zone is a place where one tectonic plate slides beneath another, and it's this process that has shaped the Pacific Northwest's landscape. The subduction of the Juan de Fuca plate beneath the North American plate creates a chain of volcanoes, each one telling a story about the region's dynamic geological history. These volcanoes are not just fascinating to look at, they also give us important clues about what could happen in the future. Water, something we use every day without thinking, plays a huge role in shaping our planet. It's not just essential for life, it's also a major player in Earth's geological processes. Water helps drive plate tectonics, the very thing that shapes the Earth's surface, and it's key in forming volcanic systems like the Cascade Range. Just as life on Earth relies on water, so does the planet's dynamic geology. When we think about plate tectonics and volcanoes, it's easy to overlook water, but it's actually pretty crucial. In the Cascades, water is involved in the process that leads to volcanoes forming. It helps to break down rocks and triggers melting in the mantle, leading to the eruptions that create those iconic mountains we see. Understanding how water works in these processes is super important. It helps us piece together the planet's geological history and also prepares us for natural hazards like earthquakes and volcanic eruptions in the Pacific Northwest and beyond. Without water, none of this would happen, just like life itself. So, how exactly does water make all this possible? To really understand that, we need to dive into the specific geological processes at play in the Pacific Northwest. Pacific Northwest. So, as we've seen, the Cascadia Subduction Zone is a big deal in the Pacific Northwest. It's where two tectonic plates meet and collide, the North American plate and the Juan de Fuca plate. The Juan de Fuca plate is made up of denser, iron-rich rock, while the North American plate is lighter, made of rock with more silicon. Because the Juan de Fuca plate is heavier, it gets pushed down, or subducted, beneath the North American plate. As the Juan de Fuca plate dives into the Earth, it brings water from the Pacific Ocean along with it. This water doesn't just sit there, it actually interacts with the minerals in the descending plate. One key mineral involved is forsterite, which is rich in magnesium. When the water mixes with forsterite, a chemical reaction happens called serpentinization. This process turns the forsterite into hydrous minerals, like serpentine, which contain water. It's pretty wild to think about. Water from the ocean, deep beneath the Earth's surface, playing a major role in shaping the geology of the region. And this water doesn't just sit around, it triggers a chain of events that leads to volcanic activity, forming the Cascade volcanoes we know today. Water does more than just mix with minerals in the Cascadia Subduction Zone. It also changes the way rocks behave. When water is pulled down into the earth with the subducting Juan de Fuca plate, it lowers the melting point of nearby rock, making it easier for solid rock to melt into magma. This is where things get interesting. The magma that forms has a lot of water in it, and as it rises, its chemistry starts to change in a process called metasomatism. As this water-rich magma starts to cool and crystallize, minerals like olivine and pyroxene begin to solidify first because they have higher melting points, around 1,200 degrees Celsius. As these iron-rich minerals form and separate out, the magma left behind becomes richer in lighter minerals like quartz and feldspar. This shift makes the magma less mafic and more silica-rich, changing it into what we call evolved magma, which is the stuff that leads to the volcanoes we see. Once the magma is more evolved, it becomes less dense than the surrounding rock, so it starts to rise toward the surface. As it moves upward, it can pick up even more silica from the continental crust it passes through, a process called assimilation. This means the magma can get even richer in silica, further changing its composition and making it even more explosive. When this evolved magma finally makes its way to the surface, it erupts and forms the iconic volcanoes of the Cascadia Subduction Zone. This whole process, which is heavily influenced by water, is at the heart of how the Cascade Range came to be. It shows us how Earth's water cycle and tectonic activity are closely connected. So, while we know water is essential for life, it also plays a huge role in shaping our planet's ever-changing landscape. The process has been happening for around 37 million years, but the volcanoes we think of today, like Mount St. Helens, Mount Hood, and Mount Rainier, are much younger, only about 2 million years old. The Cascade Range is home to around 3,000 volcanoes, and 231 of them have erupted in the past 10,000 years. That's a lot of volcanic activity in a pretty short time. It's also important to know that not all the volcanoes in the Cascades are made of silica-rich magma. A lot of the magma formed in subduction zones is still mafic, and some volcanoes, like Mount Hood and Mount Rainier, are actually made of a mix of intermediate and acidic magma. But no matter what type of magma forms, the key ingredient is still water. Water's role in the subduction process is what helps melt the underground rock and create the magma that fuels all those explosive eruptions. No matter whether the magma turns into rhyolitic rock or stays basaltic, water is the key player that drives the creation of volcanic arcs like the Cascades. This connection between water and Earth's geological processes is pretty amazing. It ties together the natural world's cycles, blending biology and geology in a way that feels both deep and poetic. Now that we've got a grip on how the Cascadia Subduction Zone and its volcanoes were formed, let's take a closer look at the raw power behind them. Crater Lake. Located in southern Oregon, Crater Lake is stunningly beautiful today, but its history is anything but calm. This deep blue lake sits inside a caldera, which is basically a giant volcanic crater formed by an explosive eruption. At 1,949 feet deep, Crater Lake is the deepest lake in the US and the 7th deepest in the world. But it wasn't always there. About 8,000 years ago, this area was home to Mount Mazama, a massive stratovolcano that towered about 12,000 feet above sea level. For around 400,000 years, Mount Mazama had been going through cycles of building up with eruptions and then tearing itself apart in violent explosions. The cataclysmic event that led to Crater Lake's creation happened around 7,700 years ago, when Mount Mazama erupted with such force that it blasted away 3,000 feet of the mountain's summit. The explosion was so intense that it caused the volcano to collapse inward, forming the caldera we see today. Over time, rain and snow filled the caldera, turning it into the beautiful lake we know, with nearly 2,000 feet of water now resting in its depths. Crater Lake, tucked in the Cascade Range, is one of the wettest places in the US, so all of its water comes from precipitation. There are no rivers flowing in or out. That's why the lake has such an isolated ecosystem. Interestingly, because of this, there are no native fish in Crater Lake, Without any rivers to bring them in, the fish just never made it there. Despite its calm appearance, the lake isn't completely still. Beneath the surface, there's still a huge reservoir of magma, and hydrothermal activity continues deep down. Even though Mount Mazama, the volcano that created Crater Lake, is considered dormant right now, it's still a big deal. It ranks as the 17th most dangerous volcano in the US. If it erupted today, the ash fallout would be massive and would have serious consequences, especially for the surrounding areas. However, because Mount Mazama is pretty isolated, the immediate loss of life would likely be fewer compared to some of the more populated Cascade volcanoes. Now, when it comes to volcanoes like Mount Hood and Mount Rainier, the risks are much closer to home. These two volcanoes are right next to major cities like Portland and Seattle, and they're a serious threat not only to the people living nearby, but also to the infrastructure and economy of the Pacific Northwest. An eruption from either could cause major disruptions, and that's something the region has to prepare for. When you think of active volcanoes, there's one that really comes to mind. Mount Hood. Standing on the slopes of Mount Hood, it's hard not to feel a sense of awe. At 11,239 feet, it's the tallest mountain in Oregon. And as you've probably guessed, it's an active volcano. With that beauty comes a serious threat though. Mount Hood is close to several communities, including Hood River, Sandy, and Troutdale, which together have around 37,000 residents. The last time Mount Hood erupted was in 1781, which is only 243 years ago. This eruption, known as the Old Maid eruptions, was pretty dramatic. A lava dome near the summit called Crater Rock collapsed, and as the volcano erupted, it caused the rapid melting of ice and snow on the mountain. The result, a massive slurry of mud and rock called a lahar rushed down the mountain, destroying everything in its path. These lahars are incredibly powerful and destructive, like a fast-moving mix of concrete that's tough to stop once it's in motion. Even after almost 250 years, the land that was hit by the 1781 lahar still shows the damage. You can't even find trees growing in the spots where the mudflow hit the hardest. It's a reminder of just how dangerous Mount Hood can be. Today, the nearby communities of Sandy, Troutdale, and Hood River are still at risk of a similar disaster if the volcano erupts again. It's a real possibility that people in these areas have to keep in mind as they go about their daily lives. If Mount Hood were to erupt again, the lahars, those fast-moving mudflows, would be a huge threat. They'd tear through everything in their path: roads, buildings, cars, and sadly, people. While modern warning systems could help save many lives, the damage to homes, businesses, and infrastructure would be staggering. We're talking billions of dollars in losses, and it would likely take years to rebuild the affected areas. Now, if you've been doing some research, you might come across some sources claiming that Mount Hood last erupted in 1866. There are reports from early settlers who saw smoke, fire, and steam coming from the mountain around that time. But despite those accounts, scientists can't find any solid geological evidence to back it up. So 1781 remains the last confirmed eruption. As dangerous as Mount Hood is, it's nothing compared to this next mountain. Mount Rainier. This mountain is considered one of the most hazardous volcanoes in the US, and for good reason. Mount Rainier is massive, it has huge glaciers on its slopes, and it's dangerously close to the Seattle-Tacoma area, home to millions of people. If Mount Rainier erupted, the potential for devastation would be huge. The US Geological Survey estimates that lahars from a major eruption could put around 795,000 people in danger. These mudflows could travel more than 50 miles, reaching areas like Renton and beyond, just like they have in the past. Mount Rainier is so dangerous that it's been added to the list of decade volcanoes, which includes the world's 16 most hazardous volcanoes, according to the International Association of Volcanology and Chemistry of the Earth's interior. The fact that a single volcano could potentially endanger nearly 800,000 lives is seriously alarming. What makes Mount Rainier so threatening is its combination of massive glaciers and the potential for explosive eruptions. If it were to blow, the consequences could be catastrophic for the Pacific Northwest. Just like Mount Rainier, there are other volcanoes all around the world just waiting to erupt. Mount Peku. Mount Peku, also known as Baekdu Mountain in Korea and Changbai Mountain in China, is a stunning, active volcano located right on the border between North Korea and China. It stands tall at 2,744 meters, making it the highest mountain in both North Korea and northeast China. The mountain is famous for its massive caldera, which is home to Heaven Lake, a place that holds great cultural and historical significance for both Koreans and Chinese. One of the most well-known events in Mount Paektu's history was its catastrophic eruption in 946 CE, often referred to as the Millennium Eruption or Tianqi Eruption. This eruption is considered one of the largest in recorded history, releasing a huge amount of magma, somewhere between 13 to 47 cubic kilometers. The eruption created tephra deposits that spread out over 1,000 kilometers, leaving a lasting mark on the landscape. The caldera that formed as a result of this eruption is around 4 kilometers wide, and it now holds the serene Heaven Lake. While the volcano hasn't erupted since 1903, it's still closely watched due to the potential for future eruptions. Recent studies show that Mount Paektu is far from being a quiet, dormant volcano. Between 2002 and 2005, a series of small earthquakes raised concerns about possible magma movement under the surface. Scientists think there could be lava accumulating in a shallow magma chamber. This has led to more monitoring, with experts from North Korea, the UK, the US, and China all keeping a close eye on things. One of the more intriguing signs of activity is that researchers have found a layer of partially melted rock beneath the volcano, which suggests that magma is still present. The central part of the mountain is also rising by about 3 mm per year, which is a clear indication that there's some geological action happening beneath the surface. So while it's hard to say exactly when or how Mount Paektu might erupt again, scientists are definitely keeping it on their radar. The presence of magma and the mountain's slow rise suggest that things are still happening under the surface, but more research is needed to figure out how big the magma reservoir is and how likely an eruption might be in the near future. While Mount Paektu is stirring beneath the surface, Mount Fuji also has an interesting history of its own. Mount Fuji. Mount Fuji is one of the most iconic landmarks in Japan, standing proudly at 3,776 meters. It's not just a beautiful sight, but also an active stratovolcano that has captured the attention of tourists, climbers, and locals alike. Located about 100 kilometers southwest of Tokyo, it's a must-see destination for anyone visiting Japan. But beyond its beauty, Mount Fuji has a rich geological history that's worth exploring. Mount Fuji didn't just pop up overnight. Its history spans several different phases. Around 700,000 years ago, the northern part of the mountain started off as the Komitake volcano. This volcano wasn't as big as the Mount Fuji we know today, but it was a beginning. Then, between 16,000 to 80,000 years ago, the older Fuji volcano began to grow, and it helped form the larger structure of what would eventually become Mount Fuji. The volcano we see today, often called the New Fuji, started forming about 14,000 years ago, with eruptions that produced smoother lava flows and a mix of volcanic materials like ash and scoria. Mount Fuji has had its share of eruptions over the centuries. In fact, there have been 16 significant eruptions since the formation of the New Fuji. One of the most notable eruptions was the Hoei eruption in 1707, which lasted for several months and created a new crater. The eruption sent ash flying, blanketing areas like Edo and causing serious agricultural damage and even fatalities. Another big eruption was the Yogin eruption in 864-866, which blasted ash and cinders into the air and even caused lava flows that changed the landscape around local lakes. Interestingly, though Mount Fuji has been quiet for over 300 years, it's still considered an active volcano. There are a few reasons why it's still on the watch list for potential eruptions. First, the area around Mount Fuji has experienced seismic activity. Earthquakes, like the Genroku earthquake in 1703, have been linked to changes in volcanic pressure beneath the surface, which could stir up activity. Plus, scientists believe there are 2 magma chambers under Mount Fuji, one around 20 kilometers deep and another around 8 kilometers. If these chambers start interacting in a certain way, it could lead to an eruption. Japan's authorities keep a close eye on Mount Fuji with continuous monitoring. Recently, there have been signs like ground deformation and low-frequency earthquakes, which may indicate magma moving beneath the surface. There's also another volcano that keeps things active in the Pacific region. Mount Ruapehu. Mount Ruapehu is an active volcano sitting proudly in New Zealand's North Island, in the Tongariro National Park. Standing at 2,797 meters, it's the tallest peak on the North Island and one of the most famous volcanoes in the country, part of the Taupo volcanic zone. It's also known by its Maori name, Ruapehu, which translates to pit of noise or exploding pit, a fitting name considering its volcanic nature. The mountain has some pretty interesting features. At its summit, you'll find a deep crater lake called Te Wai Amua. This lake is heated by geothermal energy and can reach temperatures ranging from 15 to 45 degrees Celsius. It's super acidic, with a pH level of less than 1, making it a hotspot for scientists to keep an eye on volcanic activity. Besides the crater lake, Ruapehu also has glaciers, which is unique for the North Island. These glaciers, combined with the active volcano, give the area a dramatic landscape. And it's not just a geological wonder, it's also a popular destination for outdoor enthusiasts. The mountain is home to two major ski resorts, Wakapapa and Turoa, which draw visitors all year round. Ruapehu has a long history of eruptions, with significant events happening about every 50 years or so. Some of the major eruptions occurred in 1895, 1945 to 46, and 1995 to 96. On top of these bigger eruptions, there have been around 60 smaller ones since 1945. These eruptions can produce everything from fine ash to larger volcanic blocks, and they often trigger lahars, which are volcanic mudflows that can be pretty dangerous for the surrounding areas. Despite being a major tourist destination, Ruapehu is still an active volcano that requires constant monitoring. Scientists keep a close eye on several signs that could indicate an eruption is coming. One of the biggest things they look for is seismic activity. More tremors usually mean that magma is moving beneath the surface. The temperature of the crater lake is another key indicator. If the temperature spikes, it could suggest that magma is rising. In 2022, there was a brief period of concern when the lake's temperature rose to around 40 degrees Celsius before it cooled down again. Gas emissions, particularly sulfur dioxide, are also watched closely to track any changes in the volcano's activity. While Mount Ruapehu keeps scientists busy, there's another volcano down in Ecuador that's constantly on their radar. Tungurahua. Tungurahua is one of Ecuador's most active volcanoes, and it's a pretty impressive sight. Located about 120 kilometers south of Quito, in the eastern Cordillera of the Andes, this mountain stands tall at 5,023 meters, or 16,480 feet. It's known for its steep slopes and a really interesting history of eruptions. The volcano is mainly made up of andesitic lava flows, and over time, it has gone through some pretty big changes. Tungurahua has three main parts, or edifices, with the most recent one forming after a major collapse about 3,000 years ago. This collapse left behind a huge amphitheater and a bunch of debris scattered around. Tungurahua has been pretty active, especially since it woke up again in 1999. Its eruptions since then have been pretty dramatic, with frequent explosions and ash clouds. One of the first big eruptions in this phase happened on October 5, 1999, marking the start of a new eruptive period. In 2010, it started erupting again, with big ash emissions and pyroclastic flows, those fast-moving, hot clouds of gas and volcanic debris. But the most intense period came in 2016, between February 26th and March 16th, when multiple eruptions sent ash plumes soaring as high as 6 kilometers into the air. The eruptions at Tungurahua are usually strombolian or volcanian types, which means they're explosive, and they can be accompanied by pyroclastic flows and lahars, muddy flows of volcanic debris that can travel down the volcano's slopes and affect nearby areas. Because of its frequent activity, Tungurahua is constantly being monitored. Scientists watch out for signs like increased seismic activity, which usually happens when magma is moving under the surface. They also track gas emissions, especially sulfur dioxide levels, because spikes in these gases can suggest an eruption is coming. Changes in the crater's activity, like shifts in temperature or the appearance of a crater lake, can also give clues about rising magma. One of the towns most at risk is Banos, which is really close to the volcano. The Geological Institute for the Prevention of Natural Risks in Ecuador keeps a close watch on Tungurahua, so if something major happens, they can warn people in time. Now let's head over to Hawaii, where one of the world's most active volcanoes is always putting on a show. Kilauea. Kilauea, located on the Big Island of Hawaii, is one of the most active volcanoes in the world and has been a major player in volcanic activity for centuries. What makes Kilauea so fascinating is that it's a shield volcano, meaning it has these wide, gently sloping sides formed by the flow of lava that's really fluid and runny, mostly made up of basaltic lava. This kind of lava moves easily, which is why Kilauea's eruptions tend to be less explosive than some other volcanoes, but still, they pack a punch when they erupt. Kilauea has been erupting for thousands of years, and it's part of the larger Hawaiian Emperor Seamount chain, which is essentially a stretch of underwater mountains that span deep into the Pacific Ocean. This volcano has had a massive influence on the landscape of Hawaii, and it's one of the most active places you can find when it comes to geological activity. One of the coolest features of Kilauea is its caldera, a huge crater at the summit of the volcano. Inside this caldera is the Halema'uma'u crater, which often has an active lava lake in it. Watching the lava levels rise and fall is an awe-inspiring sight. Sometimes the lava is really close to the surface, and other times it can dip pretty low, but the changes are constant, keeping scientists and visitors on their toes. The caldera and the whole area around Kilauea are like living proof of how dynamic and alive the Earth is beneath our feet. Kilauea has two major rift zones, the East Rift Zone and the Southwest Rift Zone. These are areas where the ground has cracked open and lava flows from these fissures, spilling down the slopes of the volcano. Most of the volcanic activity happens in these rift zones, and it's where we see the lava make its dramatic moves across the land, reshaping the island in real time. It's one of those things that makes the island feel like it's constantly evolving, and you're witnessing the birth of new land with every eruption. The eruptions at Kilauea have been ongoing for a long time, but one of the most dramatic periods was from 1983 to 2018, when the volcano erupted almost continuously from the Pu'u vent on the East Rift Zone. This eruption was huge, with massive lava flows that altered the landscape, destroyed homes, and caused significant damage. It wasn't just a brief outburst. This was a long-term eruption that completely transformed the land, leaving behind vast lava fields. Then came the massive 2018 eruption. It was one of the most destructive in recent history. The Pu'u cone collapsed, causing new fissures to open up in the earth, which released an even larger volume of lava. As a result, around 716 homes were destroyed, and entire communities were wiped out. It wasn't just the physical damage either. There was a massive economic cost to the eruption, with damage to infrastructure, businesses, and homes running into the hundreds of millions of dollars. It was a reminder of just how powerful and unpredictable Kilauea can be. Even after such a big eruption, Kilauea is still showing signs that it's not done yet. Scientists are constantly monitoring the volcano, especially after the eruption calmed down. There have been eruptions within the summit caldera and along the rift zones. As of late 2024, Kilauea is still active, with the Hawaiian Volcano Observatory keeping a close watch on the volcano 24/7 to stay ahead of any potential threats. What do you think? Leave your thoughts in the comments below. And if you liked this video, don't forget to subscribe to our channel. See you in the next one.